Hello students, good morning to all. I hope you all are fine. Student, today we will discuss some questions, some NCRT questions of Unit 4, Class Plus 1, Chemistry, that is chemical bonding. Okay, all questions are related to the NCRT exercise. So now move to the question number first. Our question number first is, although geometry of NH3 and water are distorted tetrahedral, bond angle in water is less than that of the ammonia. Students, in case of ammonia, this there are three bonded atoms but one lone pair here. Hybridization is sp3, but due to presence of this lone pair, it has pyramidal structure, or we can say distorted tetrahedral geometry. Distorted tetrahedral geometry. And in case of water, here oxygen has 6 valence electron. So 2 bond, it is consuming in bond formation, 2 electron, and 4 electrons are non-bonded, means 2 lone pairs are there. Okay, 2 lone pairs are there. So here hybridization also, number of bonded atom 2 and number of lone pair also 2. So 2 plus 2 4. So hybridization again sp3, and again lone pairs are present here. Due to presence of these lone pair, they have distorted tetrahedral structure. Tetrahedral geometry. Okay students, its structure is they also have distorted tetrahedral geometry. Students, its shape is bent, or we can say V shape, like this. This is V shape or bent shape, and here it has pyramidal. It has pyramidal structure. Both have distorted tetrahedral geometry, but here in case of water, angle is approx 104 degree, and in case of ammonia, it is approx 107 degree. Okay, why it is less in water as compared to the ammonia? Student, you know, for regular tetrahedral geometry, angle should be 109 degree 28 minutes. But here, in case of ammonia, here one lone pair is present. Which, and you know very well, according to the Vesper theory, lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. Okay, so students, here presence of lone pair, here repulsion, lone pair and bond pair repulsion, it is more, and repulsion, it is inversely proportional to the bond angle. If repulsion will increase, then bond angle will decrease. So here, due to lone pair bond pair repulsion, this angle decreases and it is 107 degree. But in case of water, here two lone pair exist. These two lone pair, so they will repel each other. So here, due to lone pair repulsion, further this repulsion extent is greater as compared to lone pair bond pair repulsion. So further angle decreases and this angle is 104 degree. Okay students, so because of two lone pair of electron on oxygen atom in water, repulsion on bond pair is greater in water as compared to the ammonia. In ammonia there is one lone pair. So here lone pair bond pair repulsion take place. But in case of water, there are two lone pair on oxygen atom. So due to lone pair repulsion, it is greater as compared to the lone pair bond pair repulsion. And if repulsion will be greater, then bond angle will be smaller. I hope this question is clear to you. Let's see question number 2. Our next question is, although both CO2 and water, okay, are triatomic molecule, the shape of water is bent while that of CO2, carbon dioxide, is linear. Explain this on basis of dipole moment. Students, what is the question here? Here we have again two molecules. One is CO2, carbon dioxide, and second one is water, H2O. Both are triatomic. You can see here one carbon plus two oxygen. So total atom are 1 plus 2, 3, and here also 2 hydrogen and 1 oxygen. So two total atoms, 2 plus 1, 3. So both have 3 atoms. So they are known as triatomic. Both are triatomic. But student, what will happen here? This CO2, this is linear, but it has bent structure. In previous question we have already discussed. Why it is? Explain it on basis of dipole moment. Students, you know, dipole moment of CO2 overall dipole moment is 0. But here water, it has dipole moment around 1.8 force divine. Okay, so students, here this dipole moment 0, it shows that here bond between carbon and oxygen, you know very well, carbon is tetracovalent and there are 6 valence electron in oxygen. So they will complete their octet and they will form bonds. So this carbon is forming 2 bond with this oxygen and 2 bond with this oxygen. So how can we say that? Here dipole moment is 0. So its structure will be linear. Students, you know, here oxygen is more electronegative as compared to carbon. Oxygen is more electronegative as compared to carbon. So this oxygen, it will attract the electrons of carbon towards itself. But if same element is attached in opposite direction, there is also oxygen. So with the same extent, because again it is more electronegative, so this oxygen is attracting electron towards itself, and by same extent this oxygen is attracting the electron in opposite direction towards itself. Okay, so both are attracting electron in same extent towards itself, but their direction is opposite. One is attracting in that side and one in this side, and both are attracting the electron in same extent. With same extent they are pulling. Okay, it is pulling in that side and this one is pulling in this side. With same strength they are pulling. Okay, with same strength they are pulling. So here overall dipole moment will be 0. So when it will be possible? Only it may be possible if this structure is linear, otherwise not. Okay, because in opposite direction if they will pull in with same extent, then dipole moment will be 0, otherwise not. So this is showing its dipole moment 0. It is showing that its structure should be linear. Okay students, But here this is oxygen, hydrogen. Oxygen has total 6 electron in outermost shell, forming one bond with this, one bond with this. So two lone pairs are there. Two lone pairs are there. One is lone pair bond pair repulsion, but second one, if it is linear, it is linear. Okay. So here again, dipole moment should be 0, but this band structure shows here it has some dipole moment, and this dipole moment shows that if this is linear, so they will attract or they will give electron in opposite direction. So student, what will happen? Dipole moment cannot be 0 here. Dipole moment is 1.84, and this shows that its structure will not be linear. It may be bent structure. Clear or not? So here you can see in CO2, in carbon dioxide, there are two C double bond O bonds. You can see one with this and one with this oxygen. Each carbon and oxygen bond is polar bond. You know very well oxygen is more electronegative as compared to carbon. So these bond will be polar. Bond between carbon and oxygen will be polar bond. The net dipole moment of CO2 molecule is 0. But students, here net dipole moment of CO2 is 0. And this is possible if CO2 is linear molecule, and it may be possible only when they have linear shape, linear structure, because they can cancel the moment of each other. Okay. But in case of the water, dipole moment is 1.84 divided. H2O molecule has a bent structure because here OH bond are oriented at an angle of 104.5 degree. Okay, why they have this dipole moment? Because here bond angle is around 104 degree. Okay students, so here their dipole moment shows that CO2 may be linear and water is bent structure. Our next question is, arrange the bonds in order of increasing ionic character. We have lithium fluoride, LiF, okay, K2O, potassium oxide, N2, nitrogen, SO2, sulfur dioxide, and chlorine trifluoride. Students, in case of ionic bond, what are the property of the ionic character? Here, if electronegativity difference, if electronegativity difference is more, or we can say is greater, then ionic character also increases. If electronegativity difference increases between two elements, then ionic character also increases. Okay, so here you can say lithium exists in group number first, but fluorine in group number 17. So difference in electronegativity is so high. Here in between potassium and oxygen, so potassium also exists in group number first, but oxygen in 16, oxygen in 16. So here this difference is less because down the group down the group electronegative character decreases, okay, positive character increases. So here this difference is less than the electronegativity difference between lithium and fluorine. N2, it is non-polar, no, because both bond are forming between nitrogen and nitrogen and both have same electronegativity, so here it is non-polar. And sulfur and oxygen both belong to the same group, both are the group number 16 element. Here sulfur will be more positive because the group negative character decreases, but this difference is not so high, okay. Then in between chlorine and fluorine, so again both belong to the same group, so they have less electronegativity difference, means they are less ionic. So least ionic will be the this one because it has electronegativity difference 0, and here electronegativity difference is maximum. So what will be the order? Lithium fluoride, it has maximum, then potassium and iodide, okay, because their group difference there is, so electronegativity difference is more here, okay. Then ClF3, then SO2 and N2H minimum, okay. So this will be the order, this will be the order for ionic character. If electronegativity difference increases, then ionic character will if electronegativity difference increases, then ionic character also increases. Then students, see the next question. Here next question is, describe the change in hybridization if any of aluminium atom in following reaction, okay, this is the reaction given to us, this is the reaction. AlCl3 aluminium chloride we have, if it react with Cl negative, means if it will combine with this, then it convert into the Cl4 negative. Students, here what will be difference in the hybridization? What will be the difference in hybridization? So here you can see first hybridization in aluminium chloride. So here central atom is aluminium, atomic number is 13. So configuration is 283, okay. So valence electrons are 3, here 3 valence electrons, so it can form maximum 3 bonds, it can form maximum 3 bonds, and already it is forming 3 bonds, already it is forming 3 bonds with 3 chlorines, okay. So students, here hybridization, number of bonded atom 1 2 3, number of bonded atom 3, and number of lone pair, no lone pair is here because 3 valence electron and it is also forming 3 bonds, so all bonds are consumed in bond formation, so lone pair is 0, so hybridization is 3, okay. According to this, if this sum is 3, then hybridization will be sp2. So students, in case of aluminium chloride, hybridization is sp2. Hybridization is sp2. Now, after addition of chloride ion, it is giving us AlCl4 negative. Now see what will be the hybridization in this one. Here Al H 3 valence electron, 3 valence electron plus 1 negative charge is showing that it is gaining one more electron, it is gaining one more electron. So here valence electrons are 4, valence electrons are 4. Okay, so now it can form maximum 4 bonds, and it is also forming 4 bonds. Okay, negative, it is also forming 4 bonds. Okay, so here students, number of bonded atoms are 4. No lone pair is here because it can form maximum 4 bonds, and already 4 electrons are consumed in bond formation. Already it has formed 4 bonds. So lone pair 0, so its sum is 4, and 4 hybridization will be sp3. Okay, so student, you can see what will be the change in hybridization. Here hybridization of aluminum chloride, is sp2, but hybridization for AlCl4 negative is sp3. Okay, so electronic configuration, this hybridization will be sp2, and in case of AlCl4 negative, hybridization will be sp3. Here what will be the shape of this? Its shape is trigonal planar shape, because sp2 hybridization, so for sp2 hybrid, no lone pair is here, so shape will be trigonal planar. But in case of the aluminum tetrachlorate, what will be the here AlCl4 negative, hybridization will be sp3 and shape will be tetrahedral. So students, we will discuss one more question. Our last question for today. What is total number of the sigma and pi bond? Very easy question it is. C2H2. Okay, C2 make 2 carbon, H2. Okay, so you know very well carbon is tetracovalent, so it is forming triple bond. So now count. Here this is sigma bond, this is sigma bond, here 1 sigma bond and 2 pi bond. So 1, 2, 3, 3 sigma and 1, 2 pi. In this you can also calculate in same way. So this is your homework, you will try to solve this yourself. Okay students. Okay, so I hope all questions are clear to you. Thank you. Have a nice day.